So today, Arvind will be going through several different types of artificial intelligence because there is a lot of confusion about what artificial intelligence is and what it is not, and where it can be applied and where maybe it shouldn't be applied. So from that, I will pass it over to Arvind. Thank you.
Received. Thank you, Amy, and thank you to everyone who has joined us from all over the world. We are super thrilled about the kind of response we've received for this webinar, and of course, I'm really excited about the topic that we're going to be discussing today. Artificial intelligence has become quite the rage in recent years, and for all the right reasons. AI is evolving so fast that it gets almost impossible for anyone to keep up with everything that's happening in the field. And because AI is evolving so fast, it has also become almost imperative for all of us as professionals to form an opinion or the other about AI. And on one hand, while I'm really glad about the awareness that's growing rapidly because it keeps the likes of me employed, but it also leads to a lot of confusion about what AI is and isn't. And we wanted to focus this webinar on exactly that. Over the next few minutes, I'll talk you through the different kinds of AI that matter to all of us as people trying to grow businesses, maximize ROI, or optimize cost. We'll walk through some concrete examples of how AI helps us in our day-to-day lives. And of course, we'll also discuss questions that'll help us get the most out of our AI capabilities and investments as well. So without further ado, I wanted to start with a poster that a colleague of mine recently saw at the Gartner Summit that happened earlier this year. It reads, 10 years ago, we struggled to find 10 AI-enabled business applications. In 10 years, we will struggle to find any that don't. Quite honestly, I was surprised when I first saw this because I personally felt that this was outdated by at least 10 years. But I do appreciate the core of what Gartner is trying to tell us, which is AI has simply gotten really pervasive. Think about the time just about 25 years ago, which is not too long in the relative scale of the history of mankind. But in 1992, when Apple introduced one of the ancestors of Siri, the whole world started celebrating that simply because the computer was able to respond to an user word or interaction. Since then, we started playing games with AI. For a while, we didn't mind that because we were beating AI, but gone are those days. It's gotten increasingly difficult. But now, this is not too long ago, we are even letting AI tell us how to live our lives, let alone brush our teeth. Long story short, the theme is this: the world is leading towards X plus AI. It's kind of become obvious that any company, any startup, anybody who's trying to gain that competitive advantage or edge, or they are trying to leverage AI to the best extent possible in order to continue evolving and grow their possible businesses. Agreed. AI is all around us. From the moment you wake up in the morning and unlock your phone to check your messages and emails, that's AI in action. All the way to all of these, scary movies that come out. Movies like Ex Machina I saw recently. I wonder if how long um, how long there is to even get there for Ex Machina to become reality. I wouldn't be surprised if that happens quite soon. But with this, so are the buzzwords, the list of buzzwords that keep growing, along with the importance of AI as well. We even have a running competition going on. Every day with my colleagues, we talk about a buzzword that we as professionals haven't heard about so far. People talk about RPA, deep learning, machine learning, text analytics. And within machine learning, there are so many branches. What are all of these things? So over the next few minutes, at least for the rest of the presentation, please, our goal is to basically help the audience cut through the BW. Of course, BW means buzzwords. We'll talk about what is AI, what it isn't. We'll walk through some concrete examples and case studies and demos. As risky as it is, to do a live demo during a webinar. We'll brave that and try doing a couple of live demos as well. We'll also discuss questions that'll help us get the most out of, as I said, the AI investments that we do every day. So with that, I'll jump right in. Here it is. So artificial intelligence, simply put, is the ability of a computer to mimic an action of a human being. It doesn't matter how intelligent it is or not. And so, AI is broadly classified into 5 buckets. Again, there are different versions and variations and opinions about how these buckets should be split. For all the experts in the world, we still don't have one agreed upon framework, but this is our take on what's the best way to structure AI into these 5 different buckets. Starting with rule-based AI, moving on to machine learning, natural language techniques, computer vision, and artificial reality. Let's start with rule-based. Rule-based AI is all around us. Like I said, everything we do, right from unlocking our phone to listening to the car when we forget to put on the seatbelt and start driving. All of that works with a simple formula: if something, then something else, which is basically what we call as RBDS, which is nothing but rule-based decision systems. Those are all a bunch of if else. I mean, I'm kind of oversimplifying it, but think of it as if else conditions that we teach to the machine and have it perform. We won't focus much on decision systems today because we are focusing on the buzzword RPA, that stands for Robotic Process Automation. We'll walk through a case study of RPA as well, and we'll discuss more going forward. Then comes machine learning. Again, there are multiple ways. Different experts uh, try and organize machine learning into different branches. The way I've structured it is as shallow machine learning, deep machine learning, and reinforcement learning. And we'll talk through examples and use cases of each of these. And I'll also talk to you about why I've kind of structured the branches of machine learning this way. What you see here between rule-based AI and machine learning-based AI kind of forms the basis or the foundation for what you see towards the right, starting with natural language analytics. And here, there are again a bunch of buzzwords that make this up. It could be NLP, NLQ, NLU, NLG. If you want to show off that you know text analytics to somebody, yeah, please feel free to use any of these in any order. because that's what is happening today. But we'll speak about each of these things. I mean, natural language processing is basically cutting through all the noise and looking for the signals. Quite cliche, but that is what natural language processing does, because um, we've gotten so much better at capturing the unstructured data that gets generated day in and day out. I mean, unstructured data has been there all around us forever, but with the developments in technology, we've gotten so much better at capturing and also storing unstructured data. And of course, we've gotten better at leveraging all of that unstructured data, cleaning out the noise using natural language processing. Querying is natural language querying is asking the system questions, or allowing the machine to ask us questions, vice versa, in an intelligent manner. NLU and NLG kind of forms the basis of all the hype and the theories that are floating around about robots taking over the world and AI taking over the world. All of that assumes or is formed on a basic premise that a machine would be able to understand context and be able to converse as freely as a human being, and in the process get better and smarter than the human being to take over the world. So there is, a lot of work and a lot of research and a lot of applications that are getting built around NLP, NLQ, NLU, and NLG. It'll be interesting to talk about those use cases when we get to the Q&A session. And then comes computer vision. Text, as much text as it is getting generated, equal amounts of scope for leveraging pictures, images, and videos as well, right? Of course, for those who are wondering, voice is part of the natural language analytics as well. It includes text and voice. And within computer vision, we're talking about static images, analyzing static images, using static images to get better at what we do. And of course, to use live video, or using recorded video, and using that to analyze and get more insights. Then comes reality. Whoever coined this term must like oxymorons. It's artificial reality is all about the immersiveness. It's all about the experience. How immersive is a user? How immersed is a user when they are interacting with AI? And that defines what augmented, virtual, and mixed reality is. So, with that said, I do have a request or an ask of all of you. Um, you know, I do have about 5 demos that I wanted to show you all. I'm pretty sure we won't have time to go through all the 5. So, yeah, maybe I'll give you a 10-second overview of what each of these are, and then Amy would start a poll. If you could just go in there and vote for the demos that you're most interested in. You are allowed to choose multiple options, and depending on the poll and depending on how much time we have towards the end, we will kind of go through as many case studies and demos as possible. The first one here, it is a case study of a project that we are working with a client on to optimize their customer support operations, where we use a lot of natural language analytics, weed through a lot of textual data that is generated by either the customer or the tech support agent, in order to optimize costs in terms of reducing the number of contacts or dispatches, or repeat dispatches, and whatnot. Of course, it leads to much improved customer experience and satisfaction as well. And then we have a demo video of a virtual chatbot assistant. I mean, again, chatbots are getting more and more popular these days. So the application of this chatbot was to actually train those tech support agents that we were talking about. As you know, there's a lot of churn in the tech support side of things, and as new people keep coming in all the time, it gets more and more difficult to train all of those agents over and over again. So here, the chatbot assistant interacts with the agent as a customer, and tells them what's the right way to interact with the customer, what's the right diagnosis, and what's the right resolution to do as well. And then static CV with deep learning. This is a image search implementation. Um, Let me take a step back here. With all the analytics that we can do with text, there is still the basic problem of, or I include speech as well. There's still the basic problem of teaching the machine learning algorithm to understand the shortcomings of human beings in terms of, I'm talking about the spellings, the grammatical errors, the typos, and also, of course, when we're talking about voice, we'll have to train the machine learning algorithm that much more to teach different accents. For example, I really have a hard time with my Siri. We are not friends, just so you know, because Siri has such a hard time understanding me and my accent. But with respect to image and video, it's as straightforward as it can get, except for the noise, which is again much easier to handle. There is not as much ambiguity in static or dynamic images as there is in voice and text. And so again, with the advent of deep learning, the improvements in technology, there is so much work and so much adoption that's happening with respect to leveraging images and videos a lot more. And of course, that's we have more number of demos on that side. Um, Here, this was what I have here for image search implementation is a proof of concept where we added image search onto a search bar. In addition to the users searching using keywords, they can also use images. This was for a client of ours who's in the pet industry in the UK. So even if a user kind of looks at a dog collar, for example, on the street that they really like, all they have to do is take their phone, of course, with the permission of the owner of the pet, take a picture of the dog collar, upload it, and voila, the deep learning algorithm prioritizes based on shape, size, material, color, and whatnot, and will kind of give instant search results instead of trying to decipher the long sentences or the ambiguous keywords that the user type in. And then kind of a couple of fun demos for fans of Big Bang Theory. This is right up your alley, where we are trying to mimic Sheldon's favorite game, the rock paper scissors lizard Spock game. We have a demo of that, and then a kind of a more socially responsible demo where we have a drowsiness detection demo. And of course, the application could be in any cars, for example, when the drivers are driving. Or I do have a friend who's a professor, and he was asking if this demo would work on multiple people at the same time because he wanted to use that in his class. So yeah, of course, applications are endless. So these are the different demos and case studies that we have. With that, I'll move on to talking about each of these examples, starting with rule-based. And here we go. Let's start with robotic process automation. Um, first off, let me set something straight. When just because this term RPA has the word robotic in it, we anticipate a really magnificent robot, just like this one, to come in and do all the work. In reality, we are talking about hundreds of small scripts of minion robots that's working in the background to automate a lot of little things that we otherwise have to spend hours doing. So the advantage with RPA is that the software can execute scripted tasks without demanding any major system changes. And of course we can use it for both structured and semi-structured data, and we can talk about more applications. I do have a case study here, but if you are interested in RPA, we can speak about more applications here. With that, let me set the stage before playing this video here. So this client of ours, they are a leading multinational cable and broadcasting company. And even if there is a network outage in an area, and everybody knows that there was a network outage in that area, and a user calls in saying their internet is not working, the agents would still have to check a dozen other things before they go back to the customer and say, hey, this is due to a system or the network outage, and it should come back up in an hour or so. There were about 200 tickets per hour that were coming in, especially during the network outages, and that kind of meant 8,000 or 1,000 man hours per day, right? So it was a lot of money spent on just testing or checking if the signals that kind of they knew were working, they still had to perform those checks. And this is where we saw the application of RPA. Let me quickly play this video for you. So here, if you think about it, all of the tickets that got opened, that gets extracted by RPA as an Excel sheet, and it's being put into a folder. The bot opens the Excel sheet, looks at what kind of tickets have been raised, what systems have to be pinged in order to make sure all the signals are in fact green. And then kind of it needs to log into different pages in that application. It checks for all the multiple checks, and then if everything is green, RPA again updates that Excel sheet and kind of asks for that ticket to be closed without any manual effort. About 60% of all the tickets raised needed no action from the tech support agents to enable that ticket to be closed. This specific bot checked for 20 different parameters from 20 different screens of a particular application before updating that Excel sheet as no issue or some issue found. So if you think about it, what just happened was, there was data, and then, there was a bunch of algorithms or for the bot to follow. The bot took the input data, followed the algorithms, made sure that the engine ran, executed all of the steps, and then gave us the output. This is basically what happened on the RPA side. Now, if you think about, compare it with machine learning, if you can see the screen right now, the output and the algorithm switched places. This is what happens with machine learning, where we feed the engine with input data, and we also let the engine know that, hey, this is what I'm hoping to get, or this is what I'm hoping to optimize, or and then we let the engine figure out the algorithm, so that once that algorithm is zeroed in on, we can the input data goes into the algorithm there. So on one, both RPA and machine learning are used for scale, while RPA is more for automation and scale. Machine learning is more for optimization and scale, if you know what I mean. Again, like I said, under machine learning, we do have shallow learning, deep learning, and reinforcement learning. Overall, if you think about the applications of machine learning, we use machine learning for one of these four things: um, dimension reduction, clustering, classification, and regression as well. Again, there are different applications for each of these things, and we can, if we do have time, we'll talk through each each of these applications. Maybe I'll just give you a quick one or two examples. When we talk about regression, we're talking about lead scoring, for example. We are trying to understand the relationships between attributes or variables that we are trying to work with. On the investment banking or insurance side, we're talking about detecting anomalies proactively, detecting fraud proactively. When we speak about marketing or sales, we're talking about what's the ideal price point for a product, what's the ideal promo value, and whatnot, right? Um, Classification, we are talking about trying to understand behaviors, or trying to classify behaviors into different buckets. We're trying to classify whether a customer is shopping for price or shopping for value of the product itself. We are trying to classify an email into spam or not spam. We are trying to classify a customer into high risk customer or high value customer, for example. And clustering forms unsupervised learning, and we'll talk about that a little bit more, where we don't explicitly give an output variable for the machine learning to optimize against, but we are asking our machine learning algorithm to look for patterns in the data that we give them. So here we use clustering for identifying personas in our customer base, for example. And then, of course, we have dimension reduction. Here, we use a lot of dimension reduction to understand drivers, for example, understand the most significant influencing factors that lead to a certain behavior in our business. This is again broadly classified into supervised and unsupervised learning. And in addition to that, we do have reinforcement learning as well that we will talk about. Let's quickly talk about an example of shallow machine learning. Um, let's assume that with data for on the sales side of things, there's a lead qualification example that's on the screen, where with data for engagement, channel identification, blah blah blah, we are trying to understand what factors affect the MQL, so the marketing qualified leads. Again, there's different types of regressions. Each of this is a different topic for another day, but you get what I mean. Um, Again, like I said, there are multiple applications and use cases for leveraging shallow machine learning. In fact, I wouldn't be surprised if most of us use more shallow machine learning than deep learning or reinforcement learning to run our businesses today. Um, Ideally, I should be talking about reinforcement learning after I speak about deep learning as well, because reinforcement learning applies for both machine learning and deep learning. But it's just easier to use the machine learning example that we just saw to explain reinforcement learning. Reinforcement learning is basically teaching the machine through a reward system. Think about the iRobot, Roomba machine. Again, I'm not saying the iRobot Roomba machine uses reinforcement learning. It may not, but just think about how this machine works. If you switch it on and leave it in your living room, it tries to explore your living room. If it hits an obstacle, and if it understands that just hit a wall, it forms a mental map. It knows better next time, right? So reinforcement learning does the same thing. It's kind of teaching the machine learning algorithm through trial and error and a reward system as well. Again, this is um, this gives us all hope, because practitioners would understand that for a regular machine learning algorithm to work, there is a lot of manual effort that is required in order to build those training data sets. Reinforcement learning reduces the need for manually building training data sets more often than not. I'll just give you an example here. This is an example of a customer support organization, right? Where with data for the issue types, entitlements, which is basically the warranty types, the product types, the customer types, etc. Using machine learning, we can predict whether a dispatch of a part is required for this ticket or not. What reinforcement learning does is it checks if what just happened was an ideal behavior or not, and it provides the feedback loop back to the engine. And so what happens is the self-learning aspect of learning algorithms kick in. Self-driving cars, for example, uses a lot of reinforcement learning, because it's humanly impossible to manually train a self-driving car for all of the obstacles or the consequences that may or may not happen on the road. um, you know, let's move on to more interesting topics. And of course, I'm not just talking about the burger here. I'm talking about deep learning. Um, Again, deep learning opens endless opportunities for us to leverage artificial intelligence moving forward. Deep learning is a neural network based machine learning technique that learns features and tasks directly from data. Again, at the risk of oversimplifying things, let me just say, for when we are leveraging a shallow machine learning technique, we can just focus on one technique at a time. With deep learning, we are letting the deep learning algorithm to figure it out. Combining the applications of multiple shallow learning techniques into just one execution, so to speak, thanks to GPUs and multi-processing capabilities and abilities that we've grown. Take this for example. Here, I'm just this is a use case from one of my favorite startups. It's called Calorie Mama. What it does is, you just, before eating anything, you take a photo of whatever you're eating, and it gives us the calorie count of what we are trying to eat. It looks or sounds like a pretty simple application, but if you think about it in all of the different layers, first, the deep learning algorithm needs to extract all the different features. If there is, for example, a mug in the photo, it needs to understand that, hey, I'm looking for edibles, right? And then once it extracts all the features that's necessary, it needs to classify the object into different buckets, where it talks about, in this photo, there's a bun, there's meat, there's, I think, cucumbers and whatnot. Once it classifies this image into, different things, it needs to segment each of those ingredients into its respective buckets. Where we're talking about, hey, there's a bun, there's a different calorie count for that, and then there's the meat, there's a different calorie count, and so on and so forth. And then we need to do volume estimation. What if we only had half the burger, right? So the algorithm needs to be intelligent enough to understand the volumes and also calculate the calories accordingly. Here in the background, just so you know, there will be an RPA kind of a technique running in order to scrape some calorie website to understand what the calorie counts of each of these things are, before finally giving us the overall calorie count of this dish. Quickly translating this to a business use case, for example, let's talk about in the field of customer experience. For example, we have so much data, be it transactional data, customer comments, which is unstructured data, online behavior, the customers' browsing patterns and likes and dislikes online, product pricing, supply and demand attributes, the how good or bad the support organization is, our promos and marketings, all of those things plays a huge role in us getting to a holistic customer experience score. But then if put this through a neural network, there's so much happening in all of those hidden layers, right? From image recognition to next best actions to personalization outputs, etc., in order to get predicted KPIs, which then leads to us calculating an overall customer experience score. With that, hopefully you have a good understanding of uh, RPA and the different types of machine learning. Let's quickly, maybe, Amy, what was the most popular?
The most popular was the customer support optimization demo using natural language processing.
Got it. Okay,
you do have a few questions here, Arvind, so you may want to leave a little bit of time for that.
sounds good. Okay, I'll quickly talk about that case study here. So this is again for a client of ours who's a high-tech manufacturer who wanted to optimize, their customer support practice or customer support organization. Um, you know, we kind of got together and thought about all the data that is not getting used in order to optimize the customer support function. Here, we are talking about the e-support website, where again, this is kind of this this client of ours was not unique. The e-support organizations and the tech support organizations, they hardly speak with each other, leave alone leveraging data and insights from both those silos. If you think about the solution framework here, our first goal was to integrate some of those data silos, and then we started leveraging unstructured data, basically understanding the fact that the way multiple users may have unique ways to explain an issue, right? Um, my mom would explain an issue with her laptop completely differently than some of us in the call. My mom drives me crazy when she tries to explain some of those things. Um, so our first goal was to understand what those symptoms are and map it to the right issue diagnosis, because we realized that many calls, many dispatches, so much money was spent on misdiagnosis, where the agent misdiagnoses an issue. They keep sending the wrong paths over and over again before some other agent comes in and realizes, hey, this wasn't the issue in the first place. Once we understand what those what the right issue is, it's about identifying the most optimal path to resolve that issue. Think of Google Maps, for example, where we kind of feed Google Maps our origin and our destination, and Google Maps works within the parameters and the constraints that we put on it, in terms of when we say avoid tolls or reach there fastest, or whatnot. We kind of used a similar logic here to optimize the most optimize the path to resolution. And of course, as the consumption layer, this partner and eClerx, we have a web-based decision platform for the tech support agents to always understand what the next best action is. A quick snapshot of what that looks like. Here, this is kind of the UI where we feed in a service tag and feed in a symptom, and the algorithm understands what issue type this is, and then gives recommendations for the next best action for soft resolutions and hard resolutions, depending on all the historical data. With that, let me go back to this screen here. Amy, do you think we have time for another demo before we move into Q&A, or shall we finish the Q&A and come back to more demos if there is more time?
I think that at least two of these questions are semi-involved. So let's go through one or two questions and then go back to one of the demos.
Sounds good.
Okay. So for the first, we've had a couple of questions about whether the slides will be shared. We will be sharing the recording and the slides with all of the attendees. One of the questions is related to the RPA process, and you had mentioned that 200 tickets received per hour seems to be a high number, but how scalable is this technique? Can it, is 3,000 a doable, 3,000 tickets per hour doable? What is the scalability?
Oh yeah, the scalability is almost I'd like to say endless, but it's only constrained by the resources that we allocate in terms of processing power and in terms of data storage capabilities. There is no limitation for RPA as such. And again, I am not the expert in RPA within eClerx, but then the whole premise of RPA is to stitch together multiple processes to completely automate anything that can be automated. And we do have our own RPA technology called RoboWorks, and we also work with other RPA solutions out there to implement those solutions for the clients. And if you have more questions, if you want to speak about a specific use case, please do reach out to us, and we can take it offline.
Okay, and then I'm sorry, this question got cut off on me. Oh, here we go. What kind of hardware was used to receive, review, and act on the inbound events? And I think this was also around the RPA timing of your presentation.
I'm sorry, I don't have that information, but this is something we can just reach out to us offline. I'll put you in touch with the RPA in-house RPA expert, and we can get that question addressed.
Okay. And then how about this question? It came in right around the reinforcement learning portion of your presentation. And this attendee was asking how it can be used to improve business processes.
Great question. Let me give you a couple of examples. Let's just take in the marketing side of things, right now we use a lot of machine learning to do multi-touch attribution, for example, right? And when we talk about multi-touch attribution, we're talking about endless number of permutations and combinations of the different vehicles, the different channels, and the different times of those touch points that led to a sale or a conversion or an action that we are looking for from a user, right? And technologies like reinforcement learning, what it does is, it forms the baseline of, what's the conversion rate if um, X path was followed, for example. And then when a new path comes in, it starts looking at whether that conversion was better or not when compared to the baseline that has already been set using historical data. And if it finds that this new path that came in did better than what's already there in the engine, it forms the feedback loop, and it kind of takes away the manual work of having to go back to the engine and updating it, where it kind of auto updates and self learns based on the trends that are coming in. It again works based on either rewarding the engine when something good happens, or penalizing the engine when something bad happens, so that the machine automatically tunes itself. And again, to give you another example, take the customer support organization, for example, right? Depending on who the agent is, there are multiple ways to solve a particular issue. Because usually they are given a list of 10 steps to follow if and when an issue comes in. And more often than not, some steps are, when followed in a specific pattern, may work better than an agent who's just blindly following all the 10 steps. And with the help of reinforcement learning, best practices that happens in small pockets in the entire floor, that gets captured and fed back into the machine learning algorithm, so that the rest of the team can leverage from the insights gained as well. Hope that answers your question.
Thank you, Arvind. I think we do have some time for another demo, and the next most popular, and actually a tied for the first one, is the dynamic CV with deep learning, the drowsiness demo, if you'd like to share that one.
Sounds good. Amy, do you want to bring up the poll again while I set up?
Sure. GoToWebinar doesn't like the idea of resharing the poll.
Okay, so hello world. This so right now, if you notice my screen, the deep learning algorithm looks at all the features of my face and kind of captures the eye and checks if it's closed or open at any point in time. And when I just come closer and close my eyes, so yes, that's how the drowsiness detection algorithm works.
Okay, I love that. I have some more questions for you. Let's see. How efficiently can machine learning be used for processes involving behavioral interactions?
I'm sorry, Amy, could you repeat that again, please?
How efficiently can machine learning be used for processes involving behavioral interactions?
Oh, yeah. There are endless applications for leveraging or use cases for leveraging machine learning to really derive behavioral patterns of any action that we are trying to deep dive on. And again, it depends on the industry you're in, the goals that you're trying to achieve, that the type of machine learning that we will use is very different. And I think just let's connect offline. This is a really good question that could take quite a bit of time for us to really discuss and brainstorm about. Um, Amy, and I did see a really good question come in. If you don't mind me answering this, the question is: it seems to me that NLP, computer vision, and reality are more methods that can apply the types of rule and ML-based ideology instead of being truly separate types. Since all of the subtypes could be boiled down to logic found within rule-based and ML, they are a higher grouping of method uses of types of AI than actual AI types. You've actually, hit the bullseye there. And let me go back to this slide. This slide, yeah, it's kind of it's very structured and neatly bucketed into different types. But if you think about applications, yeah, like you pointed out, nothing works independently. There are so many applications where we start with a rule-based algorithm, use the output of a rule-based algorithm, and feed it into a machine learning algorithm. And then it happens the opposite way as well, where we use machine learning algorithm first and then use the output of machine learning algorithms to rule based. In fact, I mean, you saw a demo of that when the RPA bot looked at the issue type. It then classified that incoming ticket into a specific issue, right? And then depending on what the issue type was, the rule based part of the algorithm kicked in and executed the checking of the different signals. And take self-driving cars for example. It uses everything, literally everything that you see on the slide. It's all packed into that one application of self-driving cars. So yeah. And with the last 2 minutes, Amy, I'd like to wrap up with this slide here, where kind of to, note to the audience, if there are just four things that I'd hope you took away from this presentation, it would be firstly, um, all the sales collateral that starts with AI powered and machine learning powered, just silently smirk because we know now that AI and machine learning is everywhere. In fact, if it's not using AI or machine learning, then there's something seriously wrong. It's not a differentiator anymore. It's never about whether or not the application uses AI or machine learning. It's about how much AI or machine learning or how much AI or machine learning is used to get as much value as possible. And when I say how much, I'm talking about the value gained. And I say this because it's as important to practice restraint as it is to understand the capabilities, the abilities, and grow those abilities and capabilities as well. Because we don't have to solve everything using rocket science. There's so much unstructured data that's getting generated that it's important for us to reevaluate the insights strategy. And then I'll wrap it up with requesting you to rethink your AI cocktail. Like I said, it's a combination of multiple tools and techniques that we will be using. So definitely think about everything that you can use to get the businesses to where we hope them to be.
Thank you so much, Arvind. Thank you for our attendees. Thank you for all of your questions. If you have any ideas, if this webinar has sparked some ideas of how maybe you can use AI to improve your business processes, please reach out to us and schedule a 30-minute consult and maybe pick Arvind's brain or one of our other AI expert brains. Thank you so much and have a great day.